To look across the Klamath Basin of Southern Oregon is to see a beautiful, peaceful land where wildlife is abundant and agriculture thrives. Interdependent, the farming industry relies on water and migrating bird populations as a means of delivering life-giving nutrients to the ground and removing unwanted vegetation, while waterfowl use farmland and land that has been set aside for forage and nesting to thrive along this stretch of the Pacific Flyway. One example of this harmonious relationship exists within the Klamath Basin National Wildlife Refuge Complex.
So in 1908, President Teddy Roosevelt established Lower Klamath National Wildlife Refuge as the first wildlife refuge for waterfowl in the United States.
Straddling the Oregon-California border and extending north, this complex of 6 refuges consists of approximately 322,000 acres of a variety of habitats, including freshwater marshes, open water, grassy meadows, coniferous forests, sagebrush and juniper grasslands, agricultural lands, and rocky cliffs and slopes. These habitats support diverse and abundant populations of resident and migratory wildlife, with 433 species having been observed on or near the refuges.
If you can picture in your mind the shape of an hourglass, the basin was the waistline or the narrow part of that hourglass.
In addition, each year, the refuges serve as a migratory stopover for about 3/4 of the Pacific Flyway waterfowl, with peak fall concentrations of over 1 million birds.
All the birds from the Flyway, as they flew from Canada and Alaska heading south for migration, would come to the basin and rest in this hourglass. And as they flew further south, and they spread out and went to places such as Mexico and California and the Southwest.
The Tule Lake National Wildlife Refuge encompasses 39,116 acres of mostly open water and croplands. Approximately 17,000 acres are leased by farmers under a program administered by the U.S. Bureau of Reclamation.
In 1905, the Bureau of Reclamation established the Klamath Reclamation Project, and the purpose of that project was to begin to drain the wetlands for agricultural purposes as this area began to be settled at the turn of the century.
Much of the water you see in the refuge has already been used and reused on farms along the Klamath Project before it is lifted and delivered to the Lower Klamath National Wildlife Refuge, the nation's first waterfowl refuge.
The water in the Klamath Project that was used by irrigators eventually made its way to Tule Lake National Wildlife Refuge, and there it built up. That was a closed basin. So that water on the other side of the ridge behind me, which is Tule Lake National Wildlife Refuge over there, that water would build up to a point that it would hit levels that they had to get rid of that water. Otherwise, it would start to flood out the area, some of the community, and certainly some of the farmland. So an idea was hatched to put a hole, dig a tunnel through that hill, Sheepy Ridge, and pump the water out of Tule Lake and pump it into the Lower Klamath National Wildlife Refuge. And it was a system that worked pretty well. The water worked its way through the project. This very intricate plumbing system had been established. The water was pumped through the hill, made it to Lower Klamath National Wildlife Refuge, and any excess water was then returned back to the Klamath River.
In 2001, Upper Klamath Lake, the West's largest body of fresh water and the source for most of the water used in the Klamath Project, was unusually low due to protracted drought. A new reality was dawning on those whose livelihoods were dependent on the Klamath River. There wasn't enough water to go around.
Other needs in the Klamath Basin were not being addressed. Needs for fish, both anadromous fish along the Klamath River, as well as sucker fish, which were indigenous to Upper Klamath Lake and some of the marshes around Tule Lake. So those fish, when they became listed as endangered, their needs, their water needs became a higher priority, and the highest priority within the Klamath Reclamation Project.
From the Klamath Lake and its tributaries down to the Pacific Ocean, hard times had befallen ranching, fishing, refuges, the tribes, and agriculture.
One of the things that the refuges didn't have is the refuges, remember, were established after the Reclamation Project. And the refuges were not a purpose of the Klamath Reclamation Project. So we effectively became last in line. And all those years when we were last in line before, it was okay, because there was always ample water to get to the refuges. But when we had other interests, the interests of endangered species, tribal trust responsibilities, when those became higher priorities, there just wasn't enough and isn't enough water left for the refuges. And therein lied our dilemma for the last 15 years or so. We've seen water delivery to the refuges slowly decline.
With some of the lake's water being held back to support endangered suckerfish, and the remainder bypassing the project and flowing directly down the Klamath River to support other fish species, farmers had to act fast to come up with an alternative means of irrigating their cropland. Deep wells were drilled.
I'm standing next to the very first well we dug. I remember the kids taking a bath in it right here. This is a high volume 4,000 gallon a minute well at 85 degrees.
These wells were capable of producing large volumes of water, but not without a price tag. Fortunately, electric rates to farmers in the basin were relatively low due to the hydroelectric dams along the river and a long-standing agreement with their operator, Pacific Corp, an arrangement that worked well until it was decided that dams would be removed, prompting a drastic and immediate increase in electric rates to farmers.
2002, 2003, 2004, we've seen nothing but rate increases. It costs a lot of money to pump water from the ground.
This increase in electric fees and rates has once again brought about uncertainty for the future of Klamath Basin farmers.
Now, we got a lot of energy problems right now for agriculture, and agriculture is looking at rates that are making it very hard to make ends meet.
Another area of concern is the health and vitality of the Tule Lake and Lower Klamath Lake National Wildlife Refuges. Lifting or pumping water from the Tule Lake Refuge into the Lower Klamath Refuge is an increasingly expensive means of delivering this much-needed resource.
So from the 1940s until just, maybe about 10 years ago, it was cost-effective to take the water from Tule Lake and pump it through the hill. And so about 75% of our water for Lower Klamath Refuge, all those years, came from Tule Lake.
Some clouds have silver linings, and that includes the ones above the Klamath Project. The wells that farmers and the refuges drilled largely delivered exactly what was expected. However, a few did not. Instead, these wells produced water that was hot.
So like everybody, we started looking for where else could there be water, and like a lot of folks, we looked underground, and we drilled some production wells to try to get some water to the wetlands. And what we found in almost every well we drilled over here on Lower Klamath Refuge, and we're standing next to one right now, was the water was hot. Too hot for us to use as just a general production well.
This is an 85-degree well. This is the very first one. It also makes for a good bath for kids when you're pump testing. And that's one of my favorite things. And when that water was running down the hill here, it was a joyous day because we tapped in a resource that's going to help us be sustainable in farming.
Out of necessity, a solution to the problem of increased electric rates has presented itself: the ability to produce electricity from geothermally heated water.
We got a number of wells like these that pump even more, that have a hot water brine that's going to create electricity. Give it and pumped back into the ground, heat it again, and then it comes back up without depleting the resource.
Constant and endless, these high-volume wells produce precisely what is needed to generate enough sustainable and environmentally friendly power to replace the 57 to 77 megawatts that will be lost when dams are removed.
I'm Mike Noonan from Noonan Farms, but today I'm wearing a different hat. Today certainly we're talking about water, and we're talking about what water can do for us, but we're talking about hot water.
Hot water, in and of itself, cannot solve the problem. It must be leveraged and converted into electricity in the most efficient way possible through cutting-edge technology.
So today I'm actually standing here about water, but for Entiv Organic Energy. We had this dream to start making power out of a resource that was low heat and high volume. And we were thinking kilowatts. And we were going to make it happen. So we started, and we've got multiple projects on the ground now. But a unique thing happened along the way. We came up with a partnership with Technip. the leader in technology and implementation for this resource, and plus multiple other resources in the oil and gas industry. So all of a sudden, as we were looking at kilowatts, that became megawatts.
The Klamath Basin is well known for having geothermal reservoirs for years and years. They are known as, in the United States, as one of the top geothermal places in America. The wells now that have been recorded in the Klamath Basin in the 190F to 230F now are economically viable at those temperatures, that 190F on up to 230, that is known in the Klamath Basin. And I think that's what we're talking about, utilizing that water and that resource. It's been around for a long time. Everybody's known it's there, but they never would go develop it to an extent because there was no way to turn it into power that was economical. Now that is the case, and Entiv has that technology, and we can take that resource and we can turn it into power in a way that benefits the community.
So Technip is a global engineering, procurement and construction contractor. We operate in 48 countries around the globe. We have 23,000 team members, and we've got a renewable energies division, and my role there is I'm program director for renewable projects. We have a collaboration going with an Icelandic firm, which is the leading engineering and consulting firm in Iceland for geothermal projects, both subsurface and power plants. And this collaboration essentially enables us to project their know-how, Icelandic geothermal know-how, to projects around the globe. We have also licensed, we have an exclusive license purchase agreement for a technology called the Calyx cycle that has been developed by Dr. Alexander Kalina, that is specifically suited for high volume, low temperature geothermal resources such as what we have here in the lower Klamath Lake area. So we've been working together with Entiv Organic Energy, looking at the viability of the resource. The best way to find out and have a good characterization of your resource is actually to drill into the resource at selected locations that are selected on the basis of geology or geochemistry, surface manifestations. And so essentially there's an awful lot of risk in that exercise. Now what we have here in the lower Klamath Lake area is a relatively shallow geothermal resource. The existing wells were all initially drilled back in the early 2000s for water. If you no longer necessarily have to do an awful lot more drilling, deep drilling, which is where you have the most significant cost, you essentially can very readily harness electrical energy from that high volume, relatively low temperature resource with this technology. Most traditional forms of technology require resources that are at least, say, 250 degrees Fahrenheit for it to be economic. What we have here is a technology that enables one to go down potentially lower than 200 degrees Fahrenheit and still find an economic, let's say, sweet spot. Given it always depends on what the local electricity pricing is, power pricing, and the local, local power needs are, obviously. But in any case, we see a good potential to apply the Calyx cycle technology to the specific geothermal resource that Entiv Organic Energy has made available to the project.
Building a facility of this caliber requires know-how. Every detail has to be right, or all the technology in the world won't make any difference.
We've been involved in the process piping and steam piping and pressure piping business I started right out of high school, and my father's been in it since the 70s, and we have broadened into civil construction, so we do ground up projects, turnkey. We pretty much handle anything and everything that has to do with building a project from the dirt to the finished product and turning it over to the client.
The particular attraction of this project is that you have a group of project developers that are willing to move with rapidity, making appropriately considered decisions based upon very detailed technical advice that we're getting from our Manvit colleagues in Iceland.
We have a fabrication shop. We actually have 4 buildings that we do different piping fabrication, structural steel fabrication, tank fabrication, any and all components needed to complete a project we can handle there. What we do not do in-house, we have partnerships with electrical companies and such that we work tightly together on large projects to complete them on time and on budget.
Essentially, they have access to a drilling rig, and are able to make or they are able essentially to start drilling as soon as they feel comfortable with the advice they've received. So it means that the project can move rapidly forward.
One of the things that you'll find is that there are not very many companies that have within their geothermal power companies that have within their organization drillers, and that's one of the things that we really bring to this, is that that's what we do. You don't have to go out and hire outside company in order to and contract that work out. You also have, what I bring to the table is my years of experience in the geothermal field and learning about it and trying to understand it, and then also partnering within the company to promote and develop geothermal power.
This project is kind of a cooperation with the Fish and Wildlife, as we know, and we're working together with them. I think they're going to have a pretty integral part in preparing the land for us and working with us to get the site prepared, and we'll work with them on setting the grades and surveying the site, and then at that point we'll start laying the foundations for the plant itself to be built. Technip will be designing all the equipment and providing the layout for us, and we will build it.
But the attraction of this project is from Technip's point of view, is that it's moving real quick, but in a considered fashion, taking into account the technical data out there. We are developing conceptual models of the geothermal resource. We are highlighting the risks as we go along, the principal key risks, developing risk mitigation strategies before necessarily proceeding to the next step. So I think it's a very very business-like, very orderly approach to the development.
We're all looking to make this project very pleasing to the eye, make it small in stature, so that it has very limited impact. We're looking at probably the size of a football field squared, and nothing's going to be extravagantly tall, and there will probably be some landscaping or something to that effect incorporated into it, so it is pleasing to the eye.
Well, our company is working to develop what we call a commercial showcase project, looking specifically at a low temperature type of application, because it would be basically a first of kind application in a very low temperature resource that hitherto in this country is not being exploited. So that's really the big push from our companies. We see an opportunity to essentially, showcase the advantages and the strengths of this technology that enables you simply to expand significantly the electric power base from geothermal resources in this country.
Well, what's unique about this project in general is we're going to use some of the power produced by this plant to power the pumps that fill the wildlife refuge. So there's been a shortage of power and cost that have kept them from keeping the wetlands full, and we're going to integrate this into helping keep those wetlands full to give habitat for the birds and the animals out there.
10 years ago, these wells seemed to be a great solution to solve some of our water issues. Turned out that wasn't the case then, but today, with hot water, it may exactly be what we need to do. And this wetland that sits out behind me, the one that's dry, it should be wet. We should have water out here. We should have birds. The snow geese I'm hearing flying around right now could be landing out there if there was water in it, but there's not. What we could do is generate enough power to help move water around this basin. And in doing so, this will be wet again. You know, we've had 10, 12 years at least of low water, shortages, even going completely dry. And one of the things that it has taught all of us is that we're all connected along this Klamath River. It isn't just the Klamath Project. It's not just folks who fish on the Klamath River for salmon. It's not just folks that use Upper Klamath Lake or rely on suckers. It's not just a tribal issue. It's not just a fisherman issue. It's not just a farmer's issue. And it certainly isn't just a wildlife issue. It's all of our issues. We are a river community, and we're connected. We're connected all together. And that's how we're going to solve these problems, is by putting our heads together and working together and collaborating and coming up with solutions just like this. If we can solve some of the power issues that we're dealing with in the basin, my goodness, we are solving a huge problem that's facing us. And I think geothermal, renewable, sustainable power is a great way to start.
Entiv Organic Energy was founded in this basin with partners outside this basin that make it the credible, reliable company that it is. But what a far-reaching technology when it goes out to help an industry with hot water returns in any kind of industry that has 180 plus water and wants to turn that tail water into energy. And just the cost-efficient method of doing that is going to create all kinds of opportunities. So we're looking at a small project right now to help right here within the basin, and there couldn't be a better place to kick it off. But talk about being local, regional, nationwide, and watching this technology move across, you know, that's exciting to me, and that's the total value.
Maybe it would have been easier for farmers in the Klamath Basin to sell their farms and move on, but out of necessity came solutions. A few years ago, the solution to a dwindling water supply was wells, and out of that endeavor came yet another solution in the form of geothermal energy. In a few more years, who knows what we might accomplish, as long as there's incentive.